Okay, class, what we're going to be talking about today um, is Chapter 6, Section 2, the properties of parallelograms. So we'll get right down to it. So Chapter 6, Section 2 is about the properties of parallelograms. So the first thing um, we want to know is the first objective is understand what a parallelogram is. The second objective for today is to know all of the properties of parallelograms. And then the third objective of today is going to be use the properties of parallelograms algebraically. If we flip over, we've got a little class introduction problem concerning the polygon flowchart. With your elbow partner, place each polygon in its correct place in the flowchart. Well, the most general name we have is polygon. So as we go down this flowchart and get more specific, as you will, is the point. So we've already used polygon. So a little bit more specific than that is quadrilateral. And a quadrilateral, as you know, is a four-sided polygon. As we move down the flowchart into one direction, we're going to get a little bit more specific and now talk about the parallelograms. And parallelograms are quadrilaterals in which both pairs of opposite sides are parallel. Now there are three special kinds of parallelograms. We have squares, rectangles, and rhombuses. These are the three special kinds of parallelograms. All three of those um, classify as a parallelogram. And off to the in the other direction, we still have some quadrilaterals. They're just not classified as parallelograms. So we have trapezoids, and then we have special kinds of trapezoids known as isosceles trapezoids. So these are still quadrilaterals. They're just not considered parallelograms. As we flip over, Objective 1, definition of a parallelogram. So we just really need to understand, we just completed that flow chart, and the most general type of name we have here is a polygon, which is just a many-sided shape. And then we move down the flow chart to define what a quadrilateral is, which is a polygon in which with four sides. As we went down that flow chart into one direction, we got a little bit more specific from just saying a polygon could be a four-sided polygon, and that is a parallelogram. And a parallelogram, yes, it's a four-sided polygon, which is a quadrilateral, but if it is a quadrilateral in which both pairs of opposite sides are parallel, it can now be classified as a parallelogram, which is pretty cool. Okay? So if we have such quadrilateral, a four-sided polygon, in which both pairs of opposite sides are parallel, not only is it a quadrilateral, but now it's considered a parallelogram by definition. So the definition of parallelogram again is a quadrilateral in which both pairs of opposite sides are parallel. Okay, so here on this page, we're going to mark with tick marks, and then I'll tell you what you could write in the blanks. Okay, by definition, as we just talked about, a parallelogram by definition is a quadrilateral in which both pairs of opposite sides are parallel. So when you have a four-sided shape in which both pairs of opposite sides are parallel, by definition, it's now a parallelogram. So in blank one where it says definition, you would say a quadrilateral in which both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Excuse me, a quadrilateral in which both pairs of opposite sides are parallel. Okay, now let's get into the properties of parallelograms. If this quadrilateral is indeed a parallelogram, that would now mean this. So in number 2, in that blank, you want to write that both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. If you wanted to get really languagey and technical, you could actually just say a quadrilateral in which both pairs of opposite sides are congruent. That's in number 2. That's one of the properties of a parallelogram. Another property of a parallelogram would be that. That would be another property of a parallelogram. What I just marked was this. I basically said in terms of markings that that diagonal and diagonal ZB bisect each other. So in number 3, if you would like to write it out in words, you could write a quadrilateral in which the diagonals bisect each other. Now, some students like to say the diagonals cut each other in half. Well, I'm fine with that as well. So another property is a quadrilateral in which the diagonals cut each other in half. Another property of a parallelogram would be this. What I have just marked is that both pairs of opposite angles are congruent. One of the pairs I'm referring to is angle ZRB being congruent to angle BEZ. That pair of angles are congruent. And then the other pair of opposite angles that are congruent are angle RZE congruent to angle RBE. That's the other pair of opposite angles congruent. Another property, using something that I've already marked actually on the board, in another blank if you want to write it out, is any two consecutive angles are supplementary. Any two consecutive angles are supplementary. Any two consecutive angles are supplementary. Remembering that consecutive means in a row and supplementary means two angles that whose sum is 180 degrees. So if we can show that any two consecutive angles, that angle plus that angle equaling 180 degrees, or this angle plus this angle equaling 180 degrees, or this angle plus this angle equaling 180 degrees, or this angle plus this angle equaling 180 degrees. If we can show any two consecutive angles supplementary, then we have a parallelogram there. Okay, let's use the definition of parallelogram and its properties in some examples. So those directions there underneath objective 3 says complete the statement, give a reason for your answer. You can flip back to the previous slide to help you answer these questions. So in number 4 it says segment JK. Segment JK is congruent to what segment? Well, it would have to be congruent to segment LM because it's a parallelogram. Because in a parallelogram, opposite sides are congruent. So the blank there would be segment LM. Number 5, angle MLK. Angle MLK, that would be that angle, would be congruent to what angle? Well, in a parallelogram, opposite angles are congruent. So the angle it would be congruent to is the blue angle that I've just highlighted for you. So the blank for number 5 would be angle KJM. In number 6, it says angle JKL is congruent to what angle? Well, again, in a parallelogram, opposite angles are congruent. So that angle would be congruent to the angle opposite of it, which I'm now highlighting for you in red. So the blank for number 6 would be angle J. Well, I can't see the letters, I apologize. The blank for number 6 should read angle JML. Angle JML, the red angle. Number 7 reads segment JN in red would have to be congruent to segment NL in blue. Because again, in a parallelogram, the diagonals cut each other in half. Therefore, the blank in number 7 should read segment NL. Moving on to number 8. Number 8 says angle MNL. Maybe that angle. So the answer to that, what angle is that angle congruent to? Well, it would be congruent to this angle that I'm highlighting in green. This is not a property of a parallelogram, but it is a concept that we have learned previously this year. And so this blue angle is definitely congruent to the angle in green. So the blank for number 8 should read angle KNJ. In fact, those two angles are made um, by what we call bow tie angles, and they're called vertical angles. And vertical angles are always congruent, so definitely those angles are congruent. However, not a property of a parallelogram. Number 9, segment NM would definitely be congruent to segment KN. So the blank for number 9 should be segment KN, the blue segment. Why? Because if that's a parallelogram, the diagonals bisect each other. Moving on to the next set of questions, the directions read find the measure in the parallelogram. And number 10, it says find the measure of angle C. Well, if measure of angle A is 65 degrees, then the measure of angle BCD has to also be 65 degrees. So the answer there is 65 degrees. And why? Because opposite angles in a parallelogram are congruent. Number 11, it says find HK. So they're asking you to find the length of this segment. Well, the length of the blue segment, FK, is 9 units. Therefore, the length of the green segment has to also be 9 units. Why? Because the diagonals cut each other in half. And last but not least, number 12. Number 12 says find the measure of angle Y. Well, what do we know? We know that angle X plus angle Y have to equal 180 degrees. And how do we know that? Because it's one of the properties of a parallelogram. Any two consecutive angles are supplementary. That means they add up to 180 degrees. And again, what do we mean by consecutive? It means two angles in a row. So we could say angle X plus angle Y equals 180 degrees. Another option would be angle Y plus angle Z equals 180 degrees, or angle Z plus angle W equals 180 degrees, or angle X plus angle W equaling 180 degrees. But in this case, the two angles we need that are consecutive, which are supplementary in parallelograms, are X plus Y. Substituting the angle measurement for angle X, solving for Y, we get the measure of angle Y equals 70 degrees. Okay, flipping over. It says finding the side lengths. It says EFGH is a parallelogram. Find EF and FG. Well, in 22, if that's a parallelogram, then FG has to be 7 units because opposite segments are congruent in parallelograms. And segment EF has to be 8 units because, again, opposite segments are congruent. I think we'll skip 23 and 24 It is very similar to 22 using properties of parallelograms. If we try and complicate things just a little bit using algebra, the directions read find the value of x and y in the parallelogram. So in 31, if that's a parallelogram, then these sides are definitely congruent. And these segments are definitely congruent. So to find x, we know x is equal to 12. And we're going to attach a label there of units because x signifies the length there. To find the measure, to find the value of y, we know that those two opposite segments are congruent. So we're going to go 3y plus 1 equals 10. Subtract 1 of both sides to rebalance the equation, giving us 3y equals 9. Then dividing by 3 to give us what y would have to equal of 9. Moving on to 32, if this is a parallelogram, then any two consecutive angles are supplementary. So the two angles that I've just circled are consecutive. And because that's a parallelogram, they're definitely supplementary. Two angles whose sum is 180 degrees. Subtracting 98 from both sides, we get what x would have to equal, which would be 82 degrees. Attaching a degree label there because x does signify a label. Well, what does the measure of angle y have to be? Well, y has to be congruent to this angle. Why? Because if that's a parallelogram, opposite angles are congruent. So y is just clearly 98 degrees because it's opposite of that angle stating 98 degrees. And in that last problem, number 33 there we're looking at, okay, if that indeed is a parallelogram, we know that the diagonals cut each other in half. So those two segments have to be congruent, which now means 2 times x has to be equivalent to 4. And if we divide by 2, we get x equals 2. And again, that now tells us that that segment and that segment are congruent. Why? Because the two diagonals cut each other in half. Therefore, 6 has to be equivalent to y minus 1. As we solve this equation, we get the value of y. Y is equal to 7. Again, I hope that these notes, concepts have helped you to gain an understanding of Chapter 6, Section 2.